All right, we're looking at section 1.2, measuring and constructing segments. First thing we're going to talk about is the ruler postulate. Ruler postulate says the points on a line can be put into a one-to-one correspondence with the real numbers. What that means is if I take 2 points and have a line segment, there we have our 2 points in a line segment, I can take a ruler or a number line and put it against that line segment at those 2 points, and I can measure that line segment with this ruler. I'm pretty much calling that point right there 0. Even though it says 2 underneath it, I'm counting that as 0. Then I'm going to count 1, 2. That line segment is 2 inches long. I could put this ruler anywhere. Could set it up with it starting at 5. It's still a 2-inch line segment because I'm still starting at what I'm calling 0. So you can always measure a line or measure a distance between 2 points by putting it on a number line, which we call a ruler. The way we use that is when we're talking about distance. The distance between any 2 points is the absolute value of the difference of the coordinates. So again, if I have my 2 points, and they measured at, I think we started with 2 and 4. If I want to find the distance between those 2 points, I'm going to subtract to find the difference. 4 minus 2, and I get 2. We have a distance of 2. Now I can also subtract the other direction. I can go 2 minus 4. The only problem here is when I do 2 minus 4, I get negative 2. You can never, ever have a negative distance. No matter what direction you're facing, you will always travel a positive distance. So the way we work with this is we find what's called the absolute value of these statements. 4 minus 2, if I put those vertical bars there, I'm talking about absolute value. Absolute value is the distance from 0. So 4 minus 2 is 2. And 2 is 2 units away from 0. So we have a positive 2. If I take the absolute value of this one down here, 2 minus 4 is negative 2. But negative 2 is 2 away from 0. So the absolute value of negative 2 is 2. So your distance will always be a positive number. No matter which direction you subtract, when you take the absolute value, you will always have the positive answer. Congruent segments are segments that have the same length. So in the diagram here we have that PQ and PQ and RS have the same measurement, the same distance between them. So PQ equals RS. Now notice up here, there's no lines above PQ and RS. When we're talking about distance, we're talking about a number, not a line segment. So the distance between PQ is a number, and that equals the same distance from R to S. But when we're talking about line segments, if we want to compare them, we're going to use this new symbol here. That's an equal sign with a little squiggly above it, a tilde. And we're going to say that PQ, line segment PQ, is congruent to line segment RS. That's how this statement is read. Line segment PQ is congruent to line segment RS. And all that means is that they have the same distance between them. In the book, you will notice that they will use these tick marks, these red lines on the lines. And what these represent is it's just kind of a shortcut to say that PQ is congruent to RS. If I draw another line here and another line here, oh, I already have a P, excuse me. Let's say B. And I put 2 red ticks on these 2 lines. I'm letting you know that even though it doesn't look like it, QB and SG are congruent lines because they both have 2 ticks on them. The distance is the same between them. RS and SG are not congruent because one has 1 tick and one has 2 ticks. The segment addition postulate says that if B is between A and C, then AB plus BC equals AC. This is something you'll be using for the rest of the year. So the small section from A to B and the small section from B to C has the same distance when you add them together as the distance from A to C. It's kind of confusing to say, so I'm going to do an example. If the distance from A to B was 5, and the distance from B to C was 7, then we could add those together and get that AC is 12. So AB plus BC will give us that total distance of AC. Do an example here. G is between F and H. FG equals 6 and FH equals 11. Find GH. Take a second, give this one a try. All right, let's see how you did. When I do these, I always draw a picture. Picture doesn't have to be exact. It's just a way to organize your thoughts. So I've got my 3 points. I know that G is between F and H. So there's my picture. I know that FG is 6. And I know that FH, the whole distance, is 11. I got to find GH. So I'm going to set up my formula. I know that the two smaller pieces, FG and GH, sum to equal the larger, FH. Now I plug in the numbers I know. FG is 6. GH, well, I don't know GH, so I'm going to leave GH alone. Remember, when I don't have a line above it, it's just a number. It's like if you were putting X there or anything else. And FH equals 11. Now I solve just like you would in algebra. I'm going to subtract 6 from both sides. And I'm going to get that GH equals 5. And that's our answer. Let's try another one. Take a second, give this one a try. Let's see how you did. Again, I'm going to draw a picture because I like pictures. It helps me organize what I'm thinking of. I know that Y is between X and Z. I know that XZ, the whole way across, is 3. Now I know that XY is 1 and 1/3. So I'm going to set up my formula. XY plus YZ equals XZ. XY is 1 and 1/3. YZ, I don't know YZ, so I'm just going to put YZ. And XZ is 3. So to solve this, I'm going to subtract 1 and 1/3. And if you did your algebra correctly, your arithmetic correctly, 3 minus 1 and 1/3 ends up giving you 1 and 2/3 as your final answer. Be careful with your fractions. If you forgot how to subtract your fractions, go to khanacademy.com or some other site, or ask your teacher. Try and remember how to subtract your fractions. I'm going to do a couple more problems here. M is between N and O. Find NO. So take a second, pause, see what you can do. All right, let's see how you did. We have our picture already, so I'm not going to have to draw that. I'm just going to set up my formula. I know that NM plus MO equals NO. Now plug in what I know. NM is 17. MO, I'm going to put this in parentheses just so we can group it. MO is 3x minus 5. And NO is 5x plus 2. All I've done is taken the distance between those 2 points, MO and NO, and I've just put in what they told me. So I haven't solved anything, haven't done anything fancy, I've just plugged in what I've been told. Now I'm going to do some algebra. So I'm going to combine my like terms. Now those parentheses don't really do a lot right now, so I can really get rid of them. So I'm going to just rewrite it here to confuse things less. I'm going to combine my like terms. 17 and 5 don't have an x with them. So 17 minus 5 is going to give me 12. I still have a 5x plus 2 over here. Okay. Now I'm going to get all my x's onto one side. I'm going to subtract 3x from both sides. I end up with 12 equals 2x plus 2. Got to get my non-x's together. Subtract 2 from both sides. I get that 2x equals 10. And the last step here, I have to divide both sides by 2. I'm left with that x equals 5. Now, I'm not done yet. The question was not, what is x? The question was, find NO. So now if I look up here, I know that NO is 5x minus 2. Well, I know what x is now. So I'm just going to put it in. Instead of an x, I'm going to put 5. 5 times 5 is 25. 25 plus 2 is 27. So NO equals 27. It's a lot of work for this one problem, but that's what you're going to be asked to do. Try one more. E is between D and F. Find DF. Let's take a look at the picture, pause it, see what you can do. Our last one here, we'll see what we got. DE plus EF equals DF. There's my standard formula. Now I'm going to plug in what I know. DE is 3x minus 1. EF is 13. And DF is 6x. So I'm going to combine my like terms. Negative 1 plus 13 is going to give me 3x plus 12. And we still have the 6x over here. I'm going to get all my x's onto one side. I'm going to subtract 3x from both sides. I'm left with 12 equals 3x. So I have to divide both sides by 3. Remember, we're always doing the inverse operation. 3 times x, so we're dividing by 3. I'm left with 4 equals x. Now again, we're not quite done because the question was not what is x. The question was find df. So again, I look back. df is 6x. Well, x is just 4 now, so it's 6 times 4, which gives me a final answer of 24. All right, you're going to have to do a lot of algebra in this section. There's quite a bit of plugging in numbers and solving for x. So make sure you're up to date on that, ask questions, and yeah, good luck.